Jai Hind everyone. I am Shruti Jain, Assistant Professor, MC Department, Ajay Kumar Garg Engineering College, Ghaziabad. The topic that I am going to discuss today is black box testing. The subject code is BMC 302 and it is covered under the subject Software Engineering. The target students for this is MCA second year, third semester students. Now let's understand first what a testing is before moving to what black box testing is. So software testing is a process of testing a software product. This testing process starts when the coding of the software is being done. Now that coding is checked or tested under the testing environment. We can identify that there are no bugs or the errors into the code that we have written, or in case if there are any errors, those errors can be rectified as per the user's requirement. So these testing strategies, they provide a framework or the set of activities that are essential for the success of the software, which may include the planning, the designing of the test cases, execution of the program with the test cases, interpretation of the outcome, and finally the collection and the management of the data that is there with this testing process. So here, to find out the errors in case there are any when we are implementing the software, and if there are any errors, then we try to debug them. We know that when a coding process is done, then the testing the software is a expensive activity in the sense that it consumes a lot of time, it consumes the resources. Along with that, it takes a lot of cost whenever we are working on the testing phase. But if the software is launched without testing, then it may lead to major drawbacks where the customer is unsatisfied or dissatisfied. Then human safety may also be involved if the software is related to something related to human health. For example, we have the medical softwares. So if there the testing is not being done, then it may be harmful for the human society. So we say that in the software life cycle, the earlier the errors are discovered and removed, the lower is the cost of their removal. Now the question comes, who should do the testing? We know that what a testing is. Why do we do the testing? Now the another question that comes up is, who should do the testing? So testing requires the developers to find out the errors in their software. If the software is very large, then we have a testing team that is separate from the developers team. But if the organization has limited number of people and the size of the software is not too big, then the developers and the testers may be the same people. What should we test? We should test the program's responses to every possible input. It means that we should test for all valid and invalid inputs. For example, if we are working on the login page and we are saying that the username should be of 12 characters. So in that case, or maybe the password should be of 12 characters, which include the uppercase, lowercase, special characters, then the non-special characters like the plus, minus, these are not included. Then in that case, we should check the testing phase, we should check whether the password that is being acceptable is as per the requirement that is given or as per the condition that is given. Or we should also check that when we are giving some invalid input, like we are giving plus, minus or the password in that form only, or the length is short, then is it also accepting it? So whenever we talk about testing doesn't mean always, it also means that we are testing on the invalid inputs also as well. So execute all the possible parts of the program, that is also very important. If suppose we have a conditional statement where we have a lot of branches coming up, the nested if else or maybe the switch case, then whatever inputs we are giving, we should try to give the inputs in such a manner that every input should come in either of the paths that are there in the if condition. If we have one input for the first path, then the second input should go for the second or the third path. So this is how all the possible paths or all the possible situations that are there in the program can be covered up. A program path can be traced through the code from the start of the program to the program termination. Two paths differ if the program executes a different statement in each or executes the same statement but in the different order. Like we have talked about the if-else. So if we talk about the if condition, so if in the if we have an if condition followed by some block of code, then we have else condition followed by a block of code, then we might have another if which is again followed by a block of code. Now in that case, we have three major paths, three different paths. The first, if the condition is true, it will execute this one. If the condition, this condition is false, but this condition is true, we have a separate path for this. If we have another condition, we'll have a separate path for this. So here we have three different paths which are identifying the path of the flow of the program. Now when I give the input, my input should be such that it covers either of this or this or this, number one. And number two, there should be multiple inputs which cover all of these parts. Like if one input is for this, then I'll try to get another input that is for this. Then I'll try to have another input that is for this path. Now we have three major terminologies when we are doing the testing. The three terminologies that we have is the test case, the test suite and the test data. Now test data is basically the data that has been the inputs that we are giving in order to test the system or to test the code or the software that we are building up. So test data is all those inputs that you are giving to the system to check whether it is performing well or not. That is only the test data, the normal inputs that we give. Now when we talk about test case is a triplet where we have a combination of the input, the state of the system and the output that we are getting or the expected output. So that triplet is in the form ISO, where I is the input that we are giving to the system. This input is basically the test data that we are giving. So this I is basically the test data. S is a state of the system at which the data is input. At any particular point of time when you are inputting the data, that is the state of the system, and the expected output that you want to get from the system. So when we have all these three, the triplet, then we call it as a test case. Test suite, the collection of all these test cases becomes a test suite. So this is the set of all the test cases with which a given software product is to be tested. We have different approaches of testing, the black box testing, white box testing. Today we'll be focusing only on the black box testing and the methodologies. Maybe in the next lectures, or we'll be focusing on the white box testing. So when we talk about the black box testing is also known as the functional testing or the behavioral testing. Here the test cases are designed using only the functional specifications of the software without any knowledge of the internal structure of the software. So here we are not concerned about how the software is working or in which language it is written or how the modules are interconnected, how is the flow of the data. That is not at all the concern when we are talking about the black box testing. So here the testers only knows the input that can be given to the system and the output they should get. So that is the major thing, the input and the expected output. An approach to testing where the program is considered as a black box because the internal structure of the code is to be ignored. So if we try to understand it with a figure, in the black box testing, the test cases are designed from an examination of the input-output values only, and no knowledge of the system design or the code is required over here. So here we have the input domain where we give the test data, the input data that we give. Then we have the system under test, that is the black box or the code without the functionalities, and this is the expected output, the output domain that we get whenever we are giving the input to the system. It is again reflected in the same manner. In the test data, the test input data that we give, we have two types of input data. The first one is where we feel that the inputs may cause some behavior, some unexpected behavior to the system. So that is this unexpected behavior input, and this is the normal input system that we give. We already discussed that whenever we are checking the system, we always try to check the system on the valid as well as the invalid input. So this can be considered as the invalid input, where the system may behave abruptly or not as per our requirement. And this is the test data where we are trying to check whether on these inputs, is it giving us the expected output or not. It enters into the system, and again we get two types of output. The first one is the output test result, that is the expected outputs that we get, and the other one is the inputs which reveal the presence of defects, maybe because we have given some of the input and the system behaved unexpectedly, and it did not give us the expected output. So today we'll be discussing about the three main approaches of the black box testing: the boundary value analysis, equivalence class partitioning, and the cause and effect graphing. Coming to boundary value analysis is done to check whether the values at the boundary level are being considered properly into the system or not, because it is often found that the system works well with the range of the inputs, but the boundary values normally get skipped up, due to which the system may give an error. So the test cases that are close to the boundary value condition, they have a higher chance of detecting an error. Boundary conditions means an input value may be a boundary just below the boundary upper side, or just above the boundary, that is the lower side of the range. For example, if we talk about the ranges, normally we have seen that there is an improper use of less than or less than equal to, or maybe less than equal to less than. This creates an effect when we are checking the values, or when we are giving the input values to the system. So let's consider a program where we have two input variables, x and y. The range of x is between a and b, and the range of y is between c and d. So this is how we have. So whenever we are checking the code, here what we'll do, we'll try to consider the values at c, d, a and b, because these are the boundary values for this particular system. So for example, if we have an input range of -3 to 10, the test values that we'll take would be -3 and 10 that are already there, plus a value just below it, that is 9, a value just near to it, that is -2, and then the middle value, any value or intermediate value between these two. That could be 0. It could be 1 as well. So test cases should exercise the minimum and the maximum numbers. Values just above the minimum and below the maximum are also to be tested. So here, the previous example that we were discussing, the values that we would consider would be c, a value just above it, the c plus 1, the value just below it, that is d minus 1. Similarly, the values a and b, along with that we can have a plus 1 and b minus 1. So the combinations of these would be some of the values that could be taken up when we are doing the boundary value testing, because these test cases will have more chance to detect an error. Intermediate values normally give us the accurate result, but when we check these values on the boundary values, just starting and the last value, that may give us an error. So the basic idea of boundary value analysis is to use input values at their minimum, just minimum, a nominal value just below their maximum and at their maximum values. So for every program, we normally have 4n+1 test cases. So we have the two inputs x and y. the range between these two are 100 and 300. So when we are finding out the ordered pairs, what we'll do, we'll take an intermediate value. When we are shifting one value, like we are changing the values, we'll try to change one value, keeping the other value as an intermediate value. So here we have taken that intermediate value as 200. So we'll start with the first one where we have fixed 200. We'll keep on changing the y coordinate. So we get 200 with 100. The value just next to it. So we have 200, 101. The intermediate value, that is 200, 200. The maximum value is 300. So we'll have 200, 299, 200, 300. This is when we have fixed the x coordinate and then we are making a change into the y coordinate. Now we'll keep the y coordinate as fixed. We'll keep on changing the x coordinate. So y coordinate is fixed over here. So we have 100, 200. The value next to 100 becomes 101. We get 101, 200. The intermediate value will also be checked. That is 200, 200. That is already covered over here. So we have skipped it here. The last value, maximum value. So we get 300, 200. The value just above it. So that becomes 299, 200. So this shows the number of test cases that can be generated with this. This is how the boundary value testing is done. So we have an example where we are working on the quadratic roots, where we find out the nature of the roots. An equation is a quadratic equation where we have ax square plus bx plus c. Real roots when the discriminant is greater than 0, imaginary less than 0, roots are equal when the discriminant is equal to 0. It is not a quadratic equation if a is equal to 0. So here we have these test cases. The first test case that we'll check for this, because we need to find out all the expected outcomes that are there. So the first one we check that at a equal to 0, it should give us that it is not a quadratic equation. Because we have three variables, we'll again change one, keeping the rest two as fixed. So b and c are fixed. We changed the values. We had the range from 0 to 100. So the values that we'll take would be 0, 1, 50, 99, 100. We changed a, keeping the rest of the values as fixed. Then we have kept these values as fixed and we have changed over here. Then we have kept these two as fixed and we have find out this. On these basis, we'll identify the expected outcomes. So if you look here, all the nature of the roots are covered. Like all these four are covered in this table. So this is how we work on the boundary value testing. Now when it comes to equivalence class partitioning, in the equivalence class what we do, we find out the classes over here. So here we have one valid class which talks about the valid range that is given to us, and two invalid classes where we have the range just below the minimum and just after the maximum of it. So here again we give the valid inputs to the system that is under the test and we get the output domains. So here if we talk about the example, we have the range that is given to us, that is specified, that is a valid class, and two are the invalid classes where the input would be less than 0. If we have the range from 0 to max, this is the range given to us, and the other one would be input to input greater than max. So again we'll consider the same question. Here what we'll do, we'll have these classes. The first one to check whether it is a quadratic equation or not. The other equivalence class would be the value less than 0. The valid would be between 1 to 100. This is for A. And the last one, A greater than 100. This all four combines the values for A. Now for B again, the valid between 0 to 100. The invalid B less than 0 and B greater than 0. Here we have considered 1 to 100 because A equal to 0 gives us a no quadratic equation. Then for C we have another 3, 1 invalid, this is valid, and 2 invalid classes. And again, we'll design a table and we'll get the results. The last one that we have is a cause-effect graphing, where we try to identify the causes and then we try to graph them in a form that we get an effect for it. So, a cause is a distinct input condition or an equivalence class of the input domains. An effect is the output condition or a system transformation. Let's see how the basic cause graph look like. We have certain causes, we have certain effects. If a cause directly goes to the effect, that is identity. If either of the causes are true, we use it with OR. If it is negation, not of the cause, the effect, suppose I say that it rains and the effect is it does not rain, that means it is the negation or the not. If we want both the conditions to be true, then we have this AND. So, we have an example. The characters in column A must be either A or B. That means we have either A or B. So, we have taken two causes. Character in column 1 is A. The character in column 1 is B. The effect would be, it is A or B. So, effect, okay. Then the next one is, the characters in column 2 must be a digit. So, we have another cause, that is, the character in column 2 is a digit. Now, it says, if both these things are there, then the file update is made. So, that is an effect. Update is made. If the character in column 1 is incorrect means we are talking about these two. Out of these, if any one is incorrect, message X is issued. So, that is another effect. And if the character in column 2 is not a digit, message Y is issued. So, this is another effect. Let's try to find out the cause and effect. The first one says, the characters in column 1 must be either A or B. So, we have the two causes with OR and we get this output. The character in the column 2 must be a digit. So, we have this C3. We have, this is C3. So, we have this as C3, this C3. Along with, it says the file update is made when these two are there. So, these two, the output of this and C3 give us the effect 1. That is, the effect 1 says that the update is made. The other one says, if the character in column 1 is incorrect, that means the negation of the output of C1 and C2. So, the negation of this will give us this. The message X is issued. The third one says that if the character in column 2 is not a digit, that is the negation of C3. So, we have the negation of C3. Here in that case, the message Y is issued. So, this is how we generate the cause and effect graph. And so, today we have discussed the three main approaches in the black box testing, where we have seen the boundary value testing, equivalence class testing, and lastly the cause and effect graph. That's all for today.